So in this section, we are going to talk about finding perimeter of triangles in and outside the coordinate plane. So the first few examples are going to be outside of the coordinate plane, and the last few examples are going to be how to find the perimeter of a triangle graphed in the coordinate plane. So when we find perimeter, you're finding the distance of the outside of a figure. So to do that, you just add up all the sides. So in this first example, we're just going to do 16 plus 15 plus 19. 16 plus 15 plus 19. And when we do that, it gives us 50. And we label it inches. So this triangle was truly to size. It's not, things in geometry class are not drawn to scale. The distance outside would be 50 inches. If we take a look at B, we're missing one of the sides. We weren't given the length of that side. But I noticed that this triangle is isosceles because of the tick marks. So if the one side is 5 yards, the other side's also going to be 5 yards. Those sides are the same. They have the same tick marks. Well, now that we know what the length of that side is, we can add them together. We can do 5 plus 5 plus 7 to get 17 yards. So that was drawn to scale, that triangle, all the way around the triangle. If you walked on the outside of it, you would walk 17 yards. If we take a look at example 2, we want to find the perimeter of this triangle. And we're going to round our answer to the nearest tenth if necessary. Well, again, we are missing one of the sides. And nothing's indicating to me that this is isosceles, so we need to find a way to find it. I notice this is a right triangle. And what we did at the beginning of this unit was the Pythagorean theorem. A squared plus b squared equals c squared. We can use the Pythagorean theorem to help us find the missing sides of a right triangle. So if you recall from the beginning of this unit, in the first lesson, if you start at the 90-degree angle and go to the side across from it, which is the hypotenuse, that is always your C. Then it doesn't matter, I'll make this bottom side my A and this side my B. Plug it into the Pythagorean theorem. So we're going to do a squared plus b squared equals c squared. Simplify it down, I get a squared plus 49 equals 121. Get a by itself, so I'm going to move the 49 over. I get a squared is equal to 121 minus 49 is 72. Continue getting that a by itself by getting rid of the square. And normally here we would round, but we're going to wait. We're just going to leave that side as radical 72. I know it seems really odd, but we're going to leave this side as radical 72 feet. If we round too early, and I guess in this particular case it doesn't really matter, but in examples that we're about to see, if you round too early, it's going to throw the accuracy of your answer off. So we have to wait to round. So for practice and future problems, we're going to hold off on rounding that side length. So now that we know the length of all three sides, we can add them all together. So we have 11 plus radical 72 plus 7. I'm going to show you in Desmos how we can add this, because you have to be very careful when you're adding a radical in your calculator. So I'm going to click out of the screen and I'm going to go to Desmos. So if we take a look at Desmos, let's add that up. We are going to do 11 plus radical 72. Be very careful. You notice how my, I guess you call it cursor, is flashing underneath the radical. We have to arrow out. If you don't arrow out and you do plus the next number, which is 7, that's not right. The 7 shouldn't be underneath the radical. So we have to arrow out. So if you look at that functions button over in that bottom right of your little keypad, if you're on Desmos, or the bottom right of your screen, right below that functions button is that arrow out button. You want to hit the right arrow to arrow out. Now my cursor is flashing outside of that radical, so we can do +7. And when we round to the nearest tenth, that 8 bumps the 4 up to a 5. So the perimeter is roughly 26.5 feet, approximately. So there you go.